Today we are diving into a fundamental aspect of software development that often gets overlooked but is crucial for building robust and maintainable code: unit testing. Have you ever experienced that sinking feeling when you make a small change in your code only to find out it's broken something else? Or perhaps you spend hours debugging issues that could have been caught early on? That's where unit testing comes to the rescue. Let's quickly look at what is the purpose of unit tests and what are the advantages. The purpose of unit tests is to verify the correctness of individual units, components, or modules of software code. Unit test focuses on a small isolated piece of code, such as function or method, and checks if it behaves as expected under various conditions. The primary goal of unit tests is to detect defects early before they propagate down the development process, ensuring code correctness, enabling code refactoring and maintenance, and promoting modular and reusable code. Unit tests also serve as executable documentation. They describe how a particular unit of code works, how it should behave, and provide examples of its usage. Alright, so now that we understand the importance of unit testing, let's talk about how to actually implement it in our projects. First thing first, you'll need a testing framework. There are many options out there, such as JUnit for Java, XCTest for Swift, and Jest for JavaScript. In this video, we will be using JUnit 5 with Java. Let's now look at some examples on how to test Java code using JUnit 5. Okay, let's start by creating a simple project using IntelliJ. Just go on File, click on New Project, and let's give it a name. I'm going to be using Java 11, and you can leave the build system as Maven. So as we can see, we have our empty project with a main class. So what we're going to do is we're going to create a new class. I'm going to call it Maths. And now inside this class, let's add some methods. So I'm going to create them as static methods. This way we will be able to utilize them without the need to instantiate an object. We want to focus on unit testing, not really on instantiating objects. So that's the main reason. So public static. So let's calculate the square. We're going to give it a single number, and you can simply return the number multiplied by itself. Let's have an add method, which is going to be adding two numbers and then returning n1 plus n2. We can then add another method called subtract. It's going to subtract number 2 from number 1. And let's just add another one. Public static int multiply int n1 and int n2. So this is going to multiply two numbers. Okay, what we want to do now is we want to test these methods. So if you remember, we want to test each method separately. So what we need to do first is create a test class, and you can do this by going inside your class, anywhere inside your class, and then pressing Command-Shift-T. This is going to appear, and click on Create New Test. This is going to show this pop-up. So we can leave everything as is. As you can see, there is a warning, JUnit 5 library not found in the module. This means that we don't have JUnit 5 as a dependency in our pom.xml. So we can fix this by clicking Fix, and hopefully IntelliJ should just import it by itself. If we go in our pom.xml file, we can see that IntelliJ has added the dependency we need, which is JUnit Jupyter. So now let's go back to our test class and let's start writing some actual tests. Let me put this on the right hand side. Let's close this. So these are the methods we want to test. So let's start with the square method. So the first thing we need is we actually want to declare a unit test, which we can do using this @test annotation. And now let's create the test. So public void, and now let's give it a significant name. So I'm going to call it test should return square. And now what we're going to do is we're actually going to calculate the square using our static method. So we are going to be doing maths.square, and let's say we want to calculate the square of 3. So what this is going to do is going to calculate the square, save it in a variable, and now we want to assert that this square value is the same as the one we expected. The square of 3 is actually 9, so we are expecting 9 to be returned. So let's see if this is actually being returned. Let's see if this SQ is actually 9, which is the value we expect. Let's run this code. As you can see, the test has passed. Let's say we had 6, for example, here. We know that the square of 3 is not 6, so this test should fail. And it also gives you the reason. So the actual value of SQ is 9. We were expecting 6, and that's wrong. Let's fix it again. As I said, unit tests are powerful when refactoring code. So let's say someone by mistake adds another operation here. Let's say they change it to the cube of a number. If we run this unit test, which was previously returning green, this is now going to fail. So this would allow us to catch this error. So I'm just gonna fix it for now. Let's rerun this and everything should be green. Okay, let's move on to the next method, which is add. So let's add the test annotation. Let's create the method. Test should return added numbers. Okay, same thing as before. The only difference is that this time we're going to be using maths.add and we're going to be adding, let's say, 10 and 15. And now we need an assertion. 10 plus 15 is 25. This is what we're expecting. Let's see if the actual method has given us the correct result. Let's run this test. As you can see, the test has passed. Let's now add some unit tests for the subtract method. So let's start with the first one, which is the basic case. Test should return subtracted greater than n2. So this is the first case where the first number is going to be greater than n2. Sub equal to maths dot subtract 10 minus 5. So 10 minus 5, we know that it should return 5. Let's verify this. Let's run it. As you can see, that's correct. Now, let's have another scenario where n2 is smaller than n2. Let's see what happens. So let's say this was 5 and this was 10. This should return minus 5. So this test is now going to fail, as you can see. This was also helpful because, as you can see, our unit test in this case was wrong. So you also need to make sure the unit tests you're writing are correct and you put some thought in them. So this should return minus 5. Let's run the test again. And this time it should pass. So this has passed. And let's simply add another unit test for our multiply method. I suggest you stop the video, you try it yourself, and then you come back here. Test should return multiply equal to maths dot multiply. Let's multiply 3 and 2. Assert equals 3 times 2 is 6. So let's see if this is working. This has passed as well. Let's just run the whole test class and we should have all the unit tests passing as expected. So as you can see, writing unit tests is quite straightforward. What you need to do is, given an input, we are expecting an output, and that's what you are checking for each method or module or whatever component you are testing. Let's now take a look at some more interesting and real-life unit test examples on a Spring Boot app. In recent videos, we built this weather REST API, which basically uses OpenWeather third-party API to get us back live weather data on a city that the user has passed. So let me quickly show you how this one works at the moment, and if you are interested, you can look at my previous video on how we build this. Let's go in our run configuration. Let's run it. Okay, so the web app has started. Let's go to Postman. We have our application listening on port 8080, and this is the path, and we're passing Milan as the city. If I click send, this is the result we get back. So let's try with a different city. London. Let's try another one. Let's say Rome. So as you can see, this is live data. We are passing a city name on this REST endpoint our application is listening to. And then the application sends the request to OpenWeather API, gets back a result. We trim down the result to just these two attributes and we send it back to the user. Okay, so we are now ready to start adding tests. Ideally, you want to add unit tests as you're writing the module or the class or the method, whatever. You wanna write the unit test as you go, but this is an exercise. We are gonna do it now. So let's stop our application from running. Let's minimize this. And I'm going to start creating unit tests from the bottom up. So what I mean is I'll first create tests for the smaller classes and we'll work our way up to the service class and then the resource class. And I also want to say I'm not going to add extensive unit testing with all the cases. I'm not going to test probably all the classes, but I'll try to test most of them so you get a feel of how they should look like. I'll also leave some out so you can add them yourself. You can actually go and try and look how you would add unit tests for those classes. I would start from adding tests for the geocoding coordinates transformer. So open up the class, and now we can simply use IntelliJ to help us create our test class for this transformer class. So press Command Shift T. And let's click on create new test. Make sure your cursor is inside the class, otherwise this is not gonna work. So let's click on create new test. We're going to be using JUnit 5. Leave everything as is. So class name is fine, destination package as well. So we don't need anything else. Press OK. And this is going to generate us a new test class inside this test folder. So what do we need? Let me close this. And let me have this one on the right, so you can see what we are testing. So we are testing this method. So to test this method, we actually need a way to call this method, and the only way is to have a transformer. So let's create a transformer. And now, before each test, because we could have multiple tests, I just want to initialize this transformer. There are different ways you can do this. I'll just show you the one I would use, and I find it easy to read as well. So let's create a setup method, and let's set up our transformer over here. So we're going to instantiate a new transformer. Okay, so let's create the actual test. So we need the test annotation, and let's give it a name. So public void. Test name should be descriptive, so test should transform geocoding coordinates to domain, because in this class, or in the transformer class, you could have multiple methods, let's say transform to entity, so we want to differentiate. Basically, what is a unit test? A unit test is given an input, you expect some output. So how do we do that? Well, we are going to create our input element. So in this case, we need a geocoding coordinates entity. So let's make it as final geocoding coordinates entity. And let's use the builder to actually create it. Let's set the longitude and the latitude. Let's give them some values. 12.0, I don't know. I'm just putting some random numbers. Okay, so this is the input, and now we actually want to call our function. We want to call this transform method and save the result. This method is supposed to return city coordinates, and we're going to use our transformer, transform to domain, and as input we're going to give this entity. Okay, so now what do? We have converted this entity object to domain object. We want to check what's here, and it should match what we have given. So we expect the city coordinates to have the same longitude and same latitude as our entity object. And to do that, we are going to use assertions. So let's assert all. Let's give it a heading. Should return domain city coordinates. And now let's do the actual assertions. So the first one is assert equals, and the expected value is entity dot get latitude. We want to make sure that city coordinates has the same value as well, and then we want to do the same with the longitude. So entity dot get longitude and city coordinates dot get longitude as well. Okay, we are ready to run our test. Let's see if this gives us an issue. As you can see, our test is passing. If this was wrong, let's say by mistake you put get longitude here, this test is going to fail. As you can see, we expected minus 12.90. the actual was 12. So unit tests are quite powerful in this sense. They help you discover mistakes you might have made. Okay, so we have created tests for our transformer class, our geocoding transformer class. Let's do the same for our open weather transformer as well. So let's open it. Let's press Command-Shift-T. Let's create a new test class. And we're ready to do the same. So it's going to be pretty similar to the other one we have just created. Here we have two methods to test. First thing is we want to instantiate an open weather transformer. And we want to initialize it same way we did as before. So we're going to use a setup method. And we are now ready to write the actual test. So in this case, we have two methods. So we want to test both of them, and each one of them is going to have a separate unit test. So test should transform open weather response entity to domain. And now, as you can see, here we're expecting open weather response entity as input. But if we go in here, you can see that this is going to be an array. So I'll just show you how I would handle this. Let's start by creating a open weather response entity. And let's just use the builder to create one. So the builder is just getting one variable as input, which is the weather. And this weather, as we see here, is a weather entity array. So what do we want to do? Let's just give it a name, weather entities. And let's create it up here. So final weather entity is going to be an array of weather entities. And what do we want to set it to? We just need one weather inside this weather entity object. So I'm just going to call it weather. And let's create this weather object up here. This weather object is going to be a single weather entity. So let's set the main. In this case, let's say rain, details, description, a lot of rain perhaps. And let's close, let's put the semicolon. We have our input object and we are ready to use it in our transformer. Our transformer is going to give us a city weather as domain object. So let's create city weather equals to transformer.transform to domain. And as input, we're going to give it the entity, which is this one here. And now we can do our assertions. Assert all should return domain weather object. And we're going to do our assertions. So assert equals, we want to make sure that the entity get weather, we're just going to have one, get main is equal to city weather dot get weather. And then we also want to add the second condition. So assert equals entity dot get weather, get description in this case, needs to be the same as city weather dot get details. So let's see if this first test works. So let's start the test. Let's run it. As you can see, it is working. Let's continue. We have another method. In this case, it's the other way around. Given a city weather object, we want to transform it to a weather response. This is quite short and simple. So let's add a new test. Public void test should transform city weather to entity. We're given as input a city weather, which is a domain object. Let's create one. City weather equals to city weather. Let's use the builder here. Give it a weather as, rain, same as before. Details, a lot of rain. And let's build this. And now we can simply call the transformer and we're expecting a weather response object as output. So this is how we can write. And this time we use the transform to entity method, which is the one we are testing. And as input, we give a city weather domain object. And now we can do our assertions. Return entity response object. Let's do the actual assertions. Assert equals city weather domain dot get weather. We want it to be equal to whatever is in the weather response dot get weather. We can copy this. Here instead has to be get details, and same here. And let's see if this works. As you can see, this is working as well. We can even run the whole test class, and both of the tests are running. So far, we have added 3 unit tests. We have tested 2 of our classes. Let's move on to the next ones. So let's move to maybe a more interesting class. Let's test our weather service class. So let me close the other tabs. Okay, so same as before, let's create a test class, Command-Shift-T. Let's create a new test class. Let's leave as default. Okay, now you will need these 2 annotations. Extend with, and let's extend with Mockito extension.class. And the second annotation is WebMVC test. And we want to test this weather service class. So you just give it the name of the class you are testing. Okay, the next thing is we want to instantiate this class, but we want to mock it because, as you can see, it's using provider classes and transformer classes. So the first thing we want to do is to actually mock these beans. So the way we can do it is we can use simple annotations. We can use mock bean and then create each of these dependencies. So the first one is geocoding provider. The next one is weather provider. Then we need the transformers, geocoding coordinates transformers. And then we want, mock bean. We want the open weather transformer. Okay, so now we have the mocks for these beans. We want to inject them into the class we are testing. So in this case, it's the weather service. And what this is going to do is going to get these mocks and then inject them inside this class, the service class we are testing. So weather service will get the mocks injected. We can see that in our weather service class, we just have one method to test. So let's see how we can test this method. We are also dependent on other classes, other provider classes and transformers to return us objects. So we will need some way to get back that mocked data. Mocked data means fake data. But let's first start by let's create a test class, a test method. So we use the test annotation. Let's give it a name. So test should return weather response. And now we are expecting as input weather request details. Let's create that object. Weather request details. I think we have the builder, so why is not? We have the builder. Weather request builder. And as input, we are just given a city, so I'm just going to put it here. If you want to make this look nicer, we can extract it as a constant. Let's call it London. As you can see, we can make it a public static final. This can be just used here. It just looks a bit neater. Probably instead of London, this should be called city. So let's refactor it quickly. Okay, so we have the input to our class. Now, the next thing is we want to mock responses from each one of these. For example, the first thing we're calling over in our service class is the geocoding provider. So let's start by mocking the geocoding provider. And to do that, I'm going to use some helper methods. So mock geocoding provider. As input, I'm going to pass it the request details. And let's create the method. You can press Option enter and then just create method. It's gonna fill it for you. I like to set them as final. We want to go into the geocoding provider and see what is the return type for this method call. It's a geocoding coordinates entity, so that's what we're expecting as a result. So we first need to build it, because then we can return it as an expected result. So we're mocking the result. Let's call it entity, and let's build a mocked entity that our provider is going to return. So let's set latitude and longitude. I'm going to set them to, let's say, 11.98 and then a 34.89. Actually, let's make them into constants, because then we need to do some assertions and it's going to be easier if we just have them. So let's refactor and introduce constant latitude. Let's do the same for this one. Let's refactor, introduce constant, and call it longitude. As you can see, it has been added here. Okay, so now we do the actual mocking. So this is where we're going to introduce a new method. It's called when. Let's import it. When geocoding provider dot get coordinates is given a weather request details. So these ones here. We then want to return this response. We want to return this entity. This is complaining because we want to add the exception to the method signature. And another thing, you can use auto import, but sometimes you might give you multiple options. So I'm just going to show you the package where this one resides and where all the other annotations are. So if you're having issues, just make sure that the imports look like this. Okay, so we want to add the exception handling here as well. We have mocked the provider. The next thing we want to mock now is the actual transformer, because we get the output from here, we put it into the geocoding coordinates transformer. So let's create a mock for that as well. We're not going to pass it anything. In this case, you can make it as specific as possible, but from now on, I'm not gonna have it this specific, because over here we can pass any, which is a keyword that says, or you can pass any kind of object. So let me just show you how to create this mock. So you can go to transform to domain, same as before. So we are expecting as output a CT coordinate. So let's create the expected output. Let's build this expected output using the builder class. We're going to set the longitude and the latitude. So we want this longitude and latitude to be the same as the one that the geocoding coordinates entity had, because that's what we're expecting our program to do. And now we can add the actual mocking. So when the geocoding transformer.transform to domain is given any kind of input, we want to return the city coordinates. So we want to import this. Okay, nice. So the next thing is now we want to do the same thing for the open weather provider and the open weather transformer as well. So let's add two more mocks. Mock weather provider. So let's do the same. Let's create this method. So this is gonna be similar to what we created for our transformer. So we can just open the project, go to our open weather transformer test. Let me just copy this first part. And now let's go back to our service test. Let's paste it here. So for description, I'm gonna refactor this and set it as a constant as well. So rain. I want to call it weather, and this one I'm going to call it details. So same as before, refactor and then select introduce constant, and I'll call it details. So this is going to put them up here. Next thing, let's do the actual mocking. So when weather provider, we call the get weather with any object, we don't really care. In theory, the more specific the better. You can do it by yourself. So So let me just show you the rest. So entity, that's the error. Let's add the exception. Okay, so we now need the last mock. Let's mock our open weather transformer. Let's create a method. This is quite simple, so we're going to return a weather response object. So we want a weather response equals to weather response.builder, and we're going to set the weather as the weather from our constants, details as details. Let's do the actual mocking. So when open weather transformer transform to entity, because we're calling it here, so we need this mock as well. Any. We then want to return this weather response. Okay, we have all of our mocks. We now need to do the actual method call in this service class, and this is going to return a weather response, and we want to save that. So final weather response equals to weather service class dot get weather given these request details. And now we can assert what this is going to return. If we have done our mocking correctly, this should work as expected. So let's do some assertions. I should return city weather response. Let's assert that the expected value is weather. We want the weather response to have the same weather that we have passed in all these mocks. So weather response dot get weather, and then we want to check that the details are the same as well. So let me just show you the imports over here. So these are the imports that I have used. It's the moment of truth. Let's see if this works. As you can see, our test is working as expected. Okay, so we have now added another unit test. Let's add a unit test for our resource class as well. So let me close some tabs. Okay, so let's open our resource class and let's create a test class for our resource. So create new test. Basically what is going to happen here is we need to simulate a way to perform a GET request over this endpoint. And when that is going to happen, we want to simulate this resource class returning us an OK status. So we're going to try to keep this simple. Let's actually start writing some code. I think it's going to make it clearer. So we need some annotations here. So extend with Mockito extension.class and web MVC test, and here we need to put the name of the class we are testing. So in this case it's weather resource class, so make sure these are correct. And now here, same as before, we can see that we have one dependency, which is our weather service class. So let's have weather service, and if you remember, we need to make it a mock bean. This is going to be a bit different. So we need auto wired, and we want to auto wire something called mock MVC. Let's import this. We need this mock bean, and then we need this mock MVC, which is going to help us perform the GET request. Let's create the input. So in this case, we have these weather request details. So you might be saying, oh, we have a string as input, not weather request details. We want to use the weather request details because this is what the weather service class is expecting as input. So it's a little bit different in this case, but you'll understand why in a minute. So let's create our test class. Public void test should return weather response. Success. Oh, sorry. Okay, so let's create this weather request details object. let's give the city. So I'm gonna call it, I don't know, let's use London again. I'm gonna make it as a constant. The next thing we now need is an actual weather response. We need the weather response because our resource class is returning a weather response. Weather response. Let's build the weather response. So we need a weather and some details. Again, we can have, let's say in this case, sunny. Very sunny, and let's transform them into constants. So refactor and click on introduce constant. Yeah, I'm gonna call it weather. And same as here, let's make it a constant as well. I'll call it details. So let's do the mocked response for our weather service class. One weather service dot get weather for request details. Let's import this. We want to return this weather response. Let's add the exception to the method signature as well. And this is where we're actually going to perform this simulated get request. So this is where we're going to use mock MVC dot perform, and we're going to perform a get request over this endpoint API v1 weather, and then we're gonna give the city as a variable, and we can just pass it like this. Let's import this static method as well. You're going to be provided with multiple choices. So from here, you need to select or.spring framework. So what is it? I'm just trying to find the one we need. So I can't see the import we need. Those don't look right. This is the one we want. We want the or.spring framework.test.web.server.request.mockmvc request builders.get. If you can't find it either, you can just copy this one. The next thing we need is undo. Let's print it as well. So I think it's gonna be nice to have it printed. This time this is being, you can find it, so that's good. And expect. What we expect is status.is okay. Let's import this. This is correct. This is how we're going to test this weather resource class. This is the main part where we actually perform a get on this endpoint, and we expect the status to be okay. So let's see if this works. As you can see, it does work. We send the request here, whether London was populated automatically. This is working as expected. We got a 200 back. This okay has checked that. I think this is all the unit tests I wanted to show you. You are free to add as many tests as you like. It's actually better to have multiple tests, also testing negative scenarios. As a challenge, you can actually add some unit tests for these provider classes. And there you have it. Unit testing is a powerful technique for improving the quality and reliability of your code. By investing a little time upfront to write tests, you can save yourself countless hours of debugging and frustration down the road. Thanks for watching. If you found this video helpful, don't forget to like, share and subscribe for more content. And as always, happy coding! I hope you enjoyed the video and found it somewhat useful to reach your goal. Please don't forget to like and subscribe, as it allows me to keep creating more and better content for you, all completely free of charge. See you on the next video.